Hello everyone and welcome on today's video. Today we will be discussing the hydraulic design of bore fields. Now, 2 weeks ago we already discussed a little bit about the hydraulic design. We talked about the Reynolds number, about laminar and turbulent flow, and how this all relates to the borehole thermal resistance, and in the end also your final bore field design. If you have not watched that video, please do so. It's linked down in the description. And if you've watched it, you will be able to better follow this video today. So today we will be discussing boreholes in series or parallel. Now, what do I mean by that? If we talk about the hydraulic configuration of bore fields, we can make a distinction between the hydraulics inside the borehole and outside the borehole. So inside the borehole, it's basically the heat exchanger you put inside the borehole. So from a hydraulics perspective, you have either a single U-tube or a double U-tube. Heat exchangers like the coaxial heat exchanger or the separatus heat exchanger will be more or less the same as the single U-tube from a hydraulic point of view for today's video. In the future, we will be making a video about the design and the hydraulic design with separatus, but that's another story. On the other hand, outside of the borehole, we have the connections between the boreholes, and those connections can be either in series or in parallel. Now, why is this important? Well, if you look into GHEtool Cloud, you see that in the fluid data tab, you have to enter the mass flow rate per borehole. And that's for some of us a little bit a strange concept, because we think about the mass flow rate of the whole bore fields instead of for the borehole itself. So that's why today's video we will be discussing how one relates to another, how we can go from a system flow rate to a borehole flow rate and the other way around. So every time you see flow rate per borehole, it's actually what you need for GHEtool Cloud. But in the end, internally, in the backend of GHEtool, it's the flow rate per pipe that's used for all the calculations of the borehole thermal resistance, of the pressure drop, and also of the Reynolds number. So today I'd like to discuss with you 5 different design options. We will be talking about single U tubes in parallel and series, about double U tubes in parallel and series, and then a combination of all. Because when you have a rather big bore field with 200, 300 boreholes, the hydraulic configuration can also become very complex. But in the end, it's just a combination of the 4 first principles in one way or another. So when we discuss the 5th option, the combined option, you will be able to apply the same principle to your own specific bore field hydraulic design, and you know how you can enter it in GHEtool Cloud. So let's get started. When we look at the single U-tube parallel case, we have the following figure. So we have 3 boreholes, each with a single U-tube. And here on the left we have our building, our heat pump, our primary pump, and we know it gives us 1 liter per second. So the whole bore field receives 1 liter per second. Well, for the parallel case, we know that this mass flow rate is divided equally amongst those 3 boreholes. So we know that every borehole receives a third, and a third. So that's what you will be entering into GHEtool Cloud. Now in the backend, as I said, the flow rate per pipe is the most important. And in this case, it's actually the same, because there is only 1 U-tube inside the borehole. So the whole flow rate goes through that same U-tube. And that's why I said earlier that the coaxial and the separatus probe are more or less the same, because there also the whole mass flow rate passes through the separatus or through the coaxial heat exchanger. So imagine now that instead of connecting those 3 boreholes in parallel, we connect them in series. And there we have the same figure. We have still a whole bore field with 1 liter per second as a flow rate, but now the whole flow rate passes through the first borehole onto the second and onto the third. So the flow rate per borehole that you should enter now into GHEtool is actually 1 liter per second instead of 0.33 liters per second. And the flow rate per pipe, here also the same reasoning, is still the 1 liter per second, because there is only 1 pipe in the borehole and it receives the whole flow rate of the system. So why is this difference important? Well, it has to do with the borehole tunnel resistance. So when you increase the mass flow rate or the flow rate of your borehole, chances are that you will end up with a turbulent flow regime which has a better heat transfer. So if we have the same system with 1 liter per second in parallel, we only get around 1/3 of the flow rate through each borehole, and perhaps that's not quite enough to receive turbulence. And if we connect them in series, we end up with 1 liter per second per borehole, which will be enough for turbulence. So that can be a reason to choose one or the other. On the other hand, you also have the problem of the pressure drop. If you have a higher mass flow rate through a pipe, you will also have a higher pressure drop. But that's something for another video. So for now it's important to know, if you choose a parallel option or a series option, the series option will allow you for having all boreholes at the same flow rate of the whole system. If we go for a double U-tube, it's important to take first a look at how that borehole is connected internally. So if you look at the right, we have the pipe coming from our system's collector, and there is a junction towards the borehole. And at the start of the borehole, we see the both U-tubes, it's a double U-tube, and they are also connected in parallel. So the flow arrives at the borehole and it's split across the 2 U-tubes and it's combined at the end. And if we then take a look at the figure in the middle, we still see our 1 liter per second coming from our system, from our heat pump, and it's again divided equally amongst those 3 boreholes. So again, as was the case with the single U-tube, we know that each borehole has a flow rate of 1/3 of a liter per second. But now, and that's important for the internal hydraulic system, it's the flow rate per pipe, it's only half that. Because now we have a double U-tube inside 1 borehole, so every mass flow rate has to be divided by 2. And this has an effect on, again, the pressure drop, but also the Reynolds number and the heat transfer. And if we now look at the final example, where we have a double U-tube in series, it's important to first take a look at the figure on the right. Before, both U-tubes were connected above, and now they're not. So now the different U-tubes inside this double U-tube borehole are handled in separate ways, let's say. So what we have here is we have our 3 boreholes, and they are connected in series. So what you can see here, we have 1 U-tube and it's connected to another U-tube and it's connected to another U-tube. And because we have a double U-tube, we have the same thing for the other combination. So this is a U-tube connected to this U-tube connected to this U-tube. And just as before, we have 1 liter per second for a total system. So we know that across every borehole there is a flow rate of 1 liter per second. So in GHEtool we again enter 1 liter per second. But how is this hydraulically coupled? Well, one combination of U-tubes is fed from the beginning, let's say from the first. So the first borehole receives the hot fluid, it goes to the second and then to the third borehole, and it's then connected to the system again. But the other combination of U-tubes is fed from the last borehole. So here the third borehole receives the hot fluid, it's then going to the second borehole and then to the first. And the reason why we go in opposite directions is because we want to have on average the same fluid temperature across all boreholes in our field. And that's because we want every borehole to exchange more or less the same heat with the underground, because that's important for our system's efficiency. So that's why we do this from both sides at the same time. And we know again that the flow rate through every pipe, which is being calculated in the backend, is half of what goes through one borehole, because there are double U-tubes. So these are the 4 basic hydraulic principles when it comes to the hydraulic design of the bore field itself. But now let's look at a more complicated example. So here we have still the same system, 1 liter per second, but now we have 6 boreholes connected to it. And those 6 boreholes have double U-tube, but they are also connected partly in series and partly in parallel. So what we do here is we always start from the smallest level. So we start with 1 borehole, and we see that it's connected in series with 2 other boreholes. And the same on the other side. So we see that we have 2 groups of 3 boreholes being connected in series. And those 2 groups are connected in parallel to one another. So what do we know then? Then if our whole system has 1 liter per second of flow rate, and we have 2 groups in parallel, then we know that the mass flow rate should be splitted amongst those 2 groups. So we know that each group receives 0.5 liters per second. And since every group has 3 boreholes in series, we know that each borehole will have the same 0.5 liters per second as a flow rate. So that's why you should enter, for this case, for this hydraulic design in GHEtool, the 0.5 liters per second. And in the backend again, the flow rate per pipe is 0.25 liters per second. So as you can see, by using the 4 basic hydraulic design principles, you can come up with the most exotic way of combining bore fields and boreholes together. And the way you should approach the total hydraulic design is by separating it in systematically smaller and smaller groups, and then work your way up for the total mass flow rate. So this was a short video related to the hydraulic design of your bore field itself. If you thought it was helpful, you can leave a like, you can subscribe, you can share it with colleagues who might also be interested in this topic. If you have further questions about GHEtool, or you want us to cover a specific question, or you want for us to make a certain tutorial, please let us know in the comments below. We'll be more than glad to create that for you. And I hope I see you next week. Take care. Bye.